Hello my dear students, welcome you all to the lecture 9 of the chapter Motion in a Straight Line. In this lecture, we are going to deal with problems based on lecture number 8. Okay, so without wasting much time, let us move on to our first question, that is the speed time graph of a particle moving along a fixed direction is shown in this figure. So here is a graph, that is speed time graph. Okay. Now you have to obtain the distance traversed. Traversed means distance travelled. Okay. The distance travelled by the particle between the time t is equal to 0 seconds to 10 seconds. Also you have to find what is the average speed of the particle over this interval. Okay, so the question is very simple. Basically they have given a speed time graph. From that speed time graph we are supposed to find the distance and the average speed. Okay, so we know that distance is nothing but it is the area of speed time graph, right? Area of speed time graph. Okay, so how to find the area? This is basically a triangle, right? This is basically a triangle. Okay, so in this triangle you can apply the formula half into base into height, right? So here what is the base of the triangle? The base of the triangle is 10 and this is the height of the triangle, right? The height of the triangle is 12. Okay, so this is basically half into base is 10 and the height is 12. Okay, so this is 120 divided by 2, that is 60 meter per second. Sorry, it is meter, right? It is meter. Okay, it is meter. Okay, meter, because we are finding distance. Okay, so that's it. Now you need to find the average speed. What is the equation for average speed? Average speed is total distance divided by total time taken, right? So we can write total distance by total time. Okay, you have to write it completely. I am writing it short in order to save time. Okay, so total distance means that is 60 meter, right? Total distance is 60 divided by what is the total time taken? That is 10. Okay, 60 by 10, that is equal to 6 meter per second. So that is the average speed. Okay, so it was a simple question, right? Let's see what is the next question. Here is the next question. The acceleration time graph of a body that is starting from rest is shown below. Okay, starting from rest means the initial velocity of the body is 0. Okay, now here is the acceleration time graph. From this acceleration time graph we have to draw the velocity time graph. Okay, we have to draw the velocity time graph. Now the B question is find the displacement in the given interval from 0 to 6 seconds. Also we have to find the distance travelled in the given interval of time from 0 to 6 seconds. So first of all we have to draw the velocity time graph from this acceleration time graph. Okay, so how to do that? First of all, let's consider this is the acceleration time graph. Okay, I am drawing that graph once again. Okay, so this is the graph. Here is 0, 1, 2, 3, 4, 5, 6. Okay, Now you have to draw the velocity time graph. Okay, velocity time graph. So this is VT graph, corresponding VT graph. Okay, you have to mark the time axis as such. Okay, so here will be 3 seconds. Here will be 6 seconds. In between you have 1 second, 2 second, 3 second and all. Okay. Okay. Now I have forgot something for this acceleration time graph. Here it is 4 and here it is something like -4, right? -4. Okay. Now what you have to do? We know that the body is starting from rest, right? So initially the velocity will be 0. So I will mark it with a different color. Initially the velocity will be 0. So here will be that, right? Now after 3 seconds, what will be the velocity? That is what you have to find. You know that velocity is the area of acceleration time graph. Do you remember that? Velocity is the area of acceleration time graph. So we have to find velocity from 0 to 3 seconds, right? We need to find the velocity from 0 to 3 seconds. Then the velocity V1 will be equal to the area. How to find the area? This is basically a rectangle. This is a rectangle, right? Up to 3 seconds it is a rectangle. So area will be length into breadth. Okay, length into breadth. That is 4 into 3. 4 into 3. That is equal to 12 meter per second. 12 meter per second. Okay. Now, also you need to find the velocity when it have completed 6 seconds. Okay, you want to find the velocity when it completed 6 seconds. Okay. So velocity from 0 to 6 seconds. Velocity from 0 to 6 seconds. So, do you remember? If you have the last concept we discussed in the previous lecture, that is if you have the graph of a vector quantity. Here acceleration time graph is a vector quantity and you are asked to find another vector quantity, that is velocity, which is the area of the given graph. Then if this area is A1, this area is A2, then you have to add A1 plus A2 considering the sign. Do you remember that? So first of all, what about A2? What about this area A2? The area A2 is also a rectangle. So it is length into breadth itself, which is, this is 3, right? Length is 3 and your breadth is -4, which is -12. Okay, which is -12. So A2 is -12 and this is your A1, right? This is the A1, which is 12 meter per second. So here the velocity at 6 seconds, that will be A1 plus A2, which is equal to 12 minus 12. You get the answer as 0. Okay, so let's plot those points. So when the time is 0, the velocity is 0 because the body is starting from rest. When the time is 3 seconds, your velocity is 12 meter per second, right? Let it be 12 meter per second. Okay. Now, when it is 6 seconds, again your velocity becomes 0. Now, let's connect those points. So, this is basically the velocity time graph. Okay. You have to choose the time 1 second, 2 second at equal distance. Okay. Here, from 0 to 3 seconds, the length is somewhat shorter than 3 to 6 seconds. Okay, that's why the graph is like this. You will get a perfect isosceles triangle. Okay, you will get an isosceles triangle. Okay. So this is what basically the velocity time graph is. Okay. Now we have completed the A question, right? Now what is the B question? Find the displacement in the given interval of time from 0 to 6 seconds. Okay. So when we go for B question, what is displacement? Displacement is again area of VT graph, right? Velocity time graph. Displacement is area of VT graph. So how to do that? When you are finding the displacement, okay, you have to add the area considering the sign, that is A1 plus A2, right? A1 plus A2. Now, here, this will be the A1, this will be A2. Okay, you want to find the area of this velocity time graph. So what about A1? A1 is basically a triangle, right? A1 is basically a triangle. So we can write half into B1 into H1 plus half into B2 into H2, right? So that is half into, what is B1? Sorry, B1. This will be B1, okay, or I'll mark it with a different color. Okay, this will be B1, this will be B2, H1 and H2 are same, that is this one. H1 or H2 is same, okay, that is this height, okay. So that will be 3, B2 is also 3, H1, H2 is 12, right? So let's write here half into 3 into 12 plus half into 3 into 12. So you can cut this 2, you can cut this 12, right? It becomes 6. 3 times 6 is 18 plus 18, which is equal to 36 meters, right? So 36 meter is the displacement from 0 to 6 seconds. Okay, from 0 to 6 seconds. Okay. Now, what about the C question? C question is you have to find the distance, which is a scalar quantity. Okay. So, how to find that? That is distance will be the area itself. You have to take the modulus. Okay. That is modulus of A1 was 18, right? Modulus 18 plus modulus 18. Your answer could be 36 meter itself. So here displacement and distance are same since these areas are positive. Okay. Now I will change this question a little bit. Okay, to give you some ideas regarding the finding the area. Okay, so I am changing this question a little bit. Listen very carefully. Okay, I'll just erase all these things. Okay, you have to copy these answers. Okay, just copy these answers. Okay, after that I will erase it. Okay, so I think you have paused the video and take the notes. Okay, now let's change this question a bit. That is, suppose if they have given this acceleration time graph and they ask you velocity from 0 to 6 seconds. Okay, as your D question, and your E question is speed from 0 to 6 seconds. Okay. So they have given you the acceleration time graph. Now there is D and E questions. Okay. In D question, they are asking you velocity, and in E question, they are asking you speed. So how to do that? Okay. Let's see how to do that. So this is the given graph, right? This is the given graph. Okay. This is 0, this is 4, this is minus 4 here. Here is acceleration, here is time, here it is 3 seconds, here it is 6 seconds. Alright. Now velocity means it is the area. So this is A1 plus A2. Alright. This will be your A1 and A1 is 12. We have already found that. Right. Now this will be A2 which is minus 12. Alright. So your velocity from 0 to 6 seconds will be 12 minus 12 which is equal to 0. Okay. Now what about the speed? That is a scalar quantity. Speed is a scalar quantity. So it can be only positive. So we can say speed is equal to modulus A1 plus modulus A2, which means modulus 12 plus modulus minus 12, which is 12 plus 12. Your answer will be 24 meter per second. Clear? 24 meter per second. Okay. So that is what you have to understand. If they ask you a vector quantity, then you have to consider the sign. If they ask you a scalar quantity like speed, then you have to consider the modulus. Okay. So that was my idea to give you a more clear concept of the theory part we have discussed in the last lecture. Okay. Now let's see the next question. The next question is the displacement time graph of two bodies A and B are shown in this figure. So there are two body A, B. Okay, and their displacement time graph is given. The ratio of velocity of A to the velocity of B. So we need to find VA by VB. Okay, VA upon VB. That is what we need to find. Okay. So you know that velocity is the slope of ST graph. That is displacement time graph. Alright. Velocity is the slope of displacement time graph. We have discussed in the previous lecture. So I have given you an equation for slope, that is m is equal to tan theta. Do you remember? M is equal to tan theta. So VA by VB means MA by MB. MA by MB. That is tan theta A divided by tan theta B. Okay. What is tan theta A? Basically, this is theta A, right? And this will be theta B. Okay, that is angle made by a line with positive x-axis. Okay, so here it is tan theta A is 30 degree by tan theta B is 60 degree. What is the answer of tan 30? It is 1 by root 3 divided by tan 60 is again root 3. So your answer could be 1 by root 3 into root 3, which is 1:3. Okay, so it was a simple question just to give you the idea that velocity is the slope of displacement time graph. Okay, so now you understand how useful was the math tool we discussed, right? Okay, now we'll go for the next question. Okay, here is the next question. That is, the displacement time graph of a moving particle is shown below. This is basically the displacement time graph. You are asked to find the instantaneous velocity of the particle in negative at the point. Okay, so the question is, at which point? They have given many points like C, D, E, F. Okay, and out of these points, at which point is the instantaneous velocity negative? Instantaneous velocity is negative. Do you remember the formula of instantaneous velocity? instantaneous velocity v is equal to dx by dt. Derivative means slope, right? Derivative means slope. Okay, so which means that velocity is the slope of velocity is the slope, which is m, of st graph. Right? Velocity is the slope of st graph. So, at which of these points will the slope be negative? Okay. So, in order to find that, let's once again draw this figure. This curve is something like this. Here is C, here is D, here is E, and here is F. Do you remember the points we discussed? That is tangent to a curve. That is, when angle is negative, the slope is negative. When angle is positive, the slope is also positive. Alright? And out of this, at C, the horizontal and the tangent will make positive angle. Right? At D, it could be 0 because tangent and the horizontal will coincide. Tangent and horizontal will coincide. Okay. What about the point D? This will be the tangent. This is the horizontal. So you will measure the angle in the clockwise direction, which means here the angle is negative, hence the slope is negative. So the answer is point E. Alright? At the point E, your slope will be negative, hence the instantaneous velocity of the particle is negative. Clear? Okay. Let's move to the next question. Okay. So here is the next question. So let's read the question. The position of an object moving along x-axis is given by x equal to a plus bt square. So let's write that here. Given data, your displacement x is equal to a plus bt square, where your a is 8.5 meter and b is 2.5 meter per second square. Okay, so a value is given as 8.5 meter, your b value is given as 2.5 meter per second square, and t is measured in seconds. Now what is the velocity at t is equal to 0 seconds and t is equal to 2 seconds? Okay, you need to find the velocity. Find the velocity at these 2 seconds, that is t is equal to 0 second and t equal to 2 seconds. Also we have to find what is the average velocity between t equal to 2 second and t equal to 4 second. Okay. So first we will find the velocity. Velocity. Okay. Do you remember velocity is the slope of displacement, or rate of change of displacement is called as velocity. So v is equal to dx by dt. This is something we discussed in the instantaneous velocity. Do you remember? So that is equal to derivative of what is x? X is given as a plus bt square with respect to dt. I know you are experts in differentiating, right? Okay. So let's see. Derivative of a with respect to t plus derivative of bt square with respect to dt. Right? So here, derivative of a is a constant. So derivative of constant is 0. Here you will take b outside. Remaining is derivative of t square with respect to dt. Do you remember this? Yes. the answer will be 2bt. Right? The answer is 2bt. Now, they are asking velocity at t is equal to 0 seconds. Let's find that. So we get the equation for velocity as 2bt. Okay. So what will be the velocity at 0 seconds? You have to substitute 0 for this. So we will be 2 into b into 0. The answer will be 0. Okay. Now, what is the velocity at t equal to 2 seconds? Okay. So you have to substitute 2. V is equal to 2 into, what is b? B is 2.5 into, again, time is 2. Alright? 2.5 into 2, 5. 5 into 2, 10. So it is 10 meter per second. So that is the answer, required answer. Okay. So you should know how to differentiate. Okay. That we have discussed during our class on math tools. Alright. Now, let's see the B part of this question. What is the average velocity? Okay. So there is a B part. What about the average velocity? We know that average velocity, V average is equal to total displacement. Okay. Total displacement from 2 seconds to 4 seconds. Okay, they have told here very clearly it is between this time t equal to 2 seconds to t equal to 4 seconds. Okay. So it can be written as displacement between 2 to 4 by time taken. Okay, that is change in time. Change in time. So that is nothing but x2 minus x1. Okay, that is first you have to find the displacement at 4 seconds. Then you find the displacement at 2 seconds. So x2 minus x1 divided by t2 minus t1. Clear? That will be your equation. So how to find that? Let's find x2. That is displacement at t equal to 4 seconds. Displacement at t equal to 4 seconds. The displacement equation is given as x is equal to a plus b t square. Alright. Now, what is a? A is 8.5, b is 2.5. Okay. So 8.5 plus 2.5 into t square is 4 square. Alright. Which is 8.5 plus 2.5 can be written as 5 by 2 into 4 square can be written as 16. Okay. So that is 8.5 plus 2 times 16. This is 8. 5 into 8, that is 40. So your answer could be 48.5 meter. Clear? So that is the displacement at time t equal to 4 seconds. Now let's find out x1, which is displacement at t is equal to 2 seconds. Okay. So let's find out that. Again the equation x is equal to a plus b t square, which is a is 8.5 plus 2.5 into 2 square, which is 8.5 plus 5 by 2 into 4. Okay. So what can you do? You can cut this 2 and 4. Let it be 2. 2 into 5 is 10. So this is 8.5 plus 10, which is equal to 18.5 meters. Alright. So you get your x2 and you get your x1. Okay. Now what is the average velocity? V average is equal to, okay, V average is equal to What is the displacement in between 2 to 4 seconds? That will be x2 minus x1, which is 48.5 minus 18.5 whole divided by, what is the change in time? That is t2 minus t1, that is 4 minus 2. Alright? 48.5 minus 18.5, that will be 30, isn't it? Yes. 30 by 4 minus 2 is 2. So your answer could be something like 15 meter per second. Okay. So you verify the numerical side. Okay. I want to give you the concept. If there is any sort of value change or a mistake in calculation, you have to clear it yourself. Okay. So this is how you do this question. Okay. So you get the idea, right? Okay. Now, let's see the last and final question. Okay. Yeah, this is the last and final question. I have told you this is the last and final question, but it is something lengthy, right? There is A, B, C, D, E, F, G. You have to find a lot of things. Okay. So this is not going to be a very simple question. Okay. So you will be learning lot of concepts by this single question. Okay. Let's see. And it was designed myself. You can see the written handwriting, right? Okay. Okay. So let's see the question. The position of a body is given by x is equal to 3t square minus 60 plus 5 is equal to 0. Okay. Here x is in meter and time t is in seconds. So you are given that your x is 3t square minus 60 plus 5. Right? Now you have to find what is the initial displacement. What is the initial displacement? Okay. So you have to remember something. Whenever we say the initial condition, okay, the time is considered to be 0 seconds. So to find initial displacement or initial velocity or initial acceleration, you have to give time is equal to 0 in their respective equation. Here they are asking initial displacement. So how to find initial displacement? You have to substitute t is equal to 0. Alright? So the displacement equation is 3t square minus 6t plus 5. You substitute 0, your answer will become 5 meter. Alright? If it becomes 0, this becomes 0, all these things will get cancelled. The remaining is plus 5. So it is 5 meter. So that is the first A question answer. Now they are asking you the initial velocity. In order to find the initial velocity, first of all, you have to find the equation for the velocity. Then substitute 0 in that equation. You get the idea? Okay. So let's go for B question. Your displacement is 3t square minus 6t plus 5. What about the velocity? Velocity is dx upon dt. How to differentiate it in a very simple way? I have told you the shortcut, right? So I can write 6t minus 6. Okay. 6t minus 6 as the answer. This will be the velocity. They are asking you the initial velocity. What is the initial velocity? Yes. You have to substitute time equal to 0. So your initial velocity will represent it as u. Okay. I will represent it as u. U is equal to, when you substitute 6 into 0, minus 6. So it is minus 6 meter per second. So that is the initial velocity. Okay, that is the initial velocity. Now the C question. The C question is a little bit different. That is, you have to find the displacement when the velocity is 0. When the velocity becomes 0, what will be the displacement of the body? In order to find that, first of all, you have to find what is the time at which the velocity becomes 0. What is the time at which the velocity becomes 0? So let's do that. Our C question. So we need the velocity to be 0, which means that our velocity equation was something like 60 minus 6, right? So that 60 minus 6 is equal to 0, which means 60 equal to 6. So that your time will be 6 by 6 equal to 1 second. So when the velocity becomes 0, your time is 1 second. Then what is the displacement? The displacement is, what is the equation for displacement? It is 3t square minus 6t plus 5, right? 3t square minus 6t plus 5. So upon substituting 1 here, it is 3 into 1 square minus 6 plus 5, which is 3 minus 6 plus 5, which is minus 3 plus 5, which is equal to 2 meter. So that is the required answer. That is the displacement when your velocity becomes 0. So when velocity becomes 0, your time becomes 1 second. Then you go and substitute that time value in the given equation of the displacement. So you get the displacement when the velocity is 0. Clear? Now, what about the D question? The velocity at t equal to 2 seconds. The velocity at t equal to 2 seconds. So what will be the velocity? Velocity at t equal to 2 seconds. Our velocity equation is 60 minus 6. So you substitute 2 here. 6 into 12 minus 6. Alright? Sorry. 6 into 12. It's not 6 into 12, right? It is 6 into 2 minus 6. That is 12 minus 6, which is equal to 6 meter per second. You get the idea? So that is the velocity at t equal to 2 seconds. Okay. Now, what is the acceleration of the particle? What is the acceleration of the particle? Let's find out. A, B, C, D, E. Again, you know that when you learn the instantaneous acceleration, or even during the concept discussion, I have told you acceleration is the rate of change of velocity, or acceleration is the slope of velocity. Do you remember this? So that is, you have to find the derivative of 60 minus 6 with respect to dt. Your answer is something like 6 meter per second square. Alright? Now I know that you are experts of differentiation. Okay, you know how to differentiate. Do basic differentiation. So you do it yourself. You get the answer as 6 meter per second square. Okay. So that's the acceleration of the particle. Now, we have completed E question. What about F? F question is, what is the acceleration at t equal to 3 seconds? At t equal to 3 seconds. As you can see here, the acceleration value is 6 meter per second square. Okay, it is a fixed value, which means that the body is actually having a constant acceleration. The acceleration will not change when the time passes, because it is not something like 60 or 60 square or 6 by t. Is it something like that? There is no t here, only a value 6 is here. So that is constant, it will not change with the time. So we can answer them. At t equal to 3 seconds, the acceleration will be 6 meter per second square only. Why? Because body have uniform acceleration. Uniform acceleration. That's the reason. Okay. Now what about the G question? The last and final question of this lecture is, what is the nature of acceleration? What is the nature of acceleration? Just we have discussed. Uniform acceleration. Because acceleration is constant. If the acceleration was varying with the time, it could have been non-uniform acceleration. Okay. So here it is Here it is uniform acceleration. Uniform acceleration. Now draw the acceleration time graph. Do you remember the acceleration time graph for a body having uniform acceleration? Here is acceleration, here is time. The value is 6 and that is fixed. Okay. So, if something is constant, then the graph will be parallel to x-axis. We have discussed that, right? Okay. So, we have completed all the questions. I hope you understood the concept of slope, area, how to do problems related to graph, right? And also how to do differentiation. And I have already teach you how to do integration, right? So, see you all in the next lecture. Bye-bye.